Okay, so I'm going to go ahead and do two videos that address the units, what I call chapter one, which is kind of still part of that first unit. And so it starts with a little discussion of symmetry. So in this question, we ask a little bit about odd and even. It's been a little while since we've done that. So remember, odd functions are one that if you could spin the graph around the origin 180 degrees, it's still going to be symmetric. And as it turns out, this graph right here has that odd or origin symmetry. This graph over here, number 3, is even, whereas this one does have symmetry, but it's not specifically around the origin as a coordinate or around the y-axis. So this one is classified as neither. So we had an odd one, we had an even one, and a neither. Now, when we move into number 4 and 5, because we're supposed to do that on these, to establish whether something was in fact even, what I was supposed to do is replace x with negative x. And you're noticing in the numerator, if you replace x with negative x, you in fact get exactly the same graph back. Nothing happened. But in the bottom, you don't actually get anything back. And so it's not the same function. It's not exactly the opposite function. So it makes it neither. Whereas in the denominator, when you replace x with negative x in number 5, notice everything comes back around and the numerator was exactly the same function as it started, but the denominator was exactly the opposite, meaning we could factor that minus out. So this one was neither, this one would be odd. Now, if I had changed this problem to say x squared plus 1, then right here would come back to something and it would actually be even. So the definition was if it was even, then when we replace x with negative x, you got the original function back. But if it was odd, you get the exact opposite of the original function back. So that's number 5. So now when we went on to number 6, it asks us to find t of b of negative 1. So when we do t of b of negative 1, that literally says let's plug negative 1 into b, and then get that answer and plug that answer into t. So I did that over here. So first thing I did is I figured out what b of negative 1 is. And honestly, I showed you the long, hard way. But if you have a calculator, you could let it kind of do some of the work for you. And so I got negative 2. So now what I need to do is plug negative 2 into function t. When I did that, some of you guys would probably leave it as negative root 32, but I noticed that, I hate the bells, 32 is 4 times 4 times 2, so 4 roots of 2. Number 7, moving on to number 7, we're going to borrow this exact same function right here and try to find its domain. Now, you want to remember that when you're looking for domain, you don't want to divide by 0 and you don't want to ever take the square root of a negative. So what I did is I immediately saw that and I factored that because I had a difference of squares. And I noticed that at both 6 and negative 6, I got 0. Now, keeping in mind I don't want to take the square root of a negative, I have to be really careful because 0 is very close to that value. I also don't want the denominator to be 0, so I can't allow negative 1 to happen. So as such, when I tried to go to the right, pick a number like 10, 36 minus 100 is that's a problem, a square root of a negative. Same over here. But everything's okay in the middle except at negative 1 where I would divide by 0. Now, in the question number 8, we just wanted to get up to number 9 right now, we asked for the domain of this one. Now again, we just want to watch that we don't take the square root of a negative, so something around negative 8 is going to be an issue, and something around negative 1 is going to be an issue because I don't want to divide by 0. So the first thing I did is I said, hey, you know, at negative 8, I can do it. I can take the square root of 0. That's fine. But I can't take the square root of negative 1. And it turns out everything over here is okay because the square root of a positive is okay to do. But I can't come over here because the square root of a negative is not. And then in the B section, it was x squared minus x minus 12. So I factored it. I found the values where 0 happened, which were 4 and negative 3. Again, -10 is a big problem because I do not want to divide by 0. And then I just check some numbers. If I plug in a number like 6, I'd get the square root of 2 times 18, which is absolutely fine. Divided by 16, it's fine. Life is great. I just don't want to have this one. And right in here, what happens is plug in a number like 0, you get -4 times 3, which is negative. I can't be there because the square root would be negative. So this is an alternative way to write that out. So this is our interval notation. This was our graphical notation. Now, question number 9 was the last one that I wanted to put in this particular portion of the video, where we took a look at a problem where we wanted to find the inverse. Now, again, one of the bummers about this particular problem is this is a parabola. Parabolas, of course, look like this. They're nice functions. They're awesome. However, they don't pass the horizontal line test. And when you take an inverse, remember the parabola turns on its side, and now all of a sudden it won't pass that test. So that's why we had to do this, is we wanted to kind of fix that domain. So we should be aware that when we look at this graph will have a vertex at -4, comma, -7. So what I did is I looked at the problem and I said, if the parabola has a vertex of -4, -7, we want to only consider the one side of the graph over here. I don't think that's going to show up very well. We're going to throw this part away. So we're only going to pick the part of the graph above -4 and above -7, keeping in mind that the domain and range of the original will become the domain and range of the inverse. I took the time to go through and swap x and y. Notice x and y were swapped here. We did a little bit of movement of things around. I moved the 7 across, divided by 2. Take a square root. Boom. Here is my inverse function. But notice that's important. Hey, what do you know? When we did our work right here, it actually established something, because at -7, this root becomes 0, and I can't go below that, or I'm going to have the square root of a negative. And that kind of finishes this portion of it, which is going to be what I call the A portion of the Chapter 1 review. Hopefully that's great for you. We'll do one more to finish up Chapter 1 before we go on to the next one. Bye-bye.